Welcome. What I want to do today is show you how to solve this equation by completing the square. So the first thing we want to do is get this in a form that completing the square is going to make sense. So what I'm going to do is I'm going to get all of my terms on one side and set them equal to 0. So by rewriting this, I can have positive 4n squared, positive 6n, minus 40 equals 0. All right? So all I did was I just brought those over to the other side and left 0 on the end. So now, remember, the main goal is, in completing the square, the first thing we want to do is we need to get a perfect square trinomial. Well, to do that, we have to first factor out a 4. So I'm going to factor out a 4 out of my first two terms. So when I factor out a 4 out of my first two terms, I'm going to be left with n squared plus 6/4 n minus 40 equals 0. Now, I can also reduce that. Whenever we have an opportunity to reduce, you always want to make sure you can take a look at it. So let's reduce this, n squared plus 3/2 n minus 40 equals 0. Okay, now we could have subtracted out of everything, but I just sometimes like to keep it this way. I always like to look at just factoring out those first two terms. You can factor the 4 out of all three terms, and in this case, it might be a little bit simpler. But I always just get used to it as you don't have to factor out this third term. You have to at least factor out to make sure at least that the 4 is factored out from the n squared. So now I need to complete the square by taking b divided by 2 and squaring it. So b, which is 3/2 divided by 2, squared, which is going to be 9/16. So I have 4 times n squared plus 3/2 n plus 9/16 minus 40 equals 0. Now remember, since I'm adding a 9/16 here, I'm also going to want to add a 9/16 over here on the other side of my equal sign. Then the other step is now I can add a 40 to the other side. And the other important thing to remember, before I add the 40 actually, let's go back here a step. I added the 9/16 to the side, but then remember that 9/16 is being multiplied by the 4. So I have to make sure I multiply this 9/16 by the 4, then I can add my 40. Don't want to go too many steps ahead. So now, the whole reason, ladies and gentlemen, why we do completing the square, to get our perfect square trinomial. So now what I can do is rewrite this as a perfect square binomial, where I can have 4 times n plus 3/4 squared. Let's take a look at that. Does that make sense? Does what two numbers multiply to give you 9/16, 3/4, and then add to give you 3/2? Will again be 3/4. Equals, now I need to combine the 9/16 times 4 plus 40. Well, this can be reduced to 9/4 plus 40/1. I can go and combine those, multiply this by 40/4, or 4/4. So that's going to be 160 over 4. So it ends up equaling 4 times n plus 3/4 squared equals 169 over 4. Now again, I'm going to divide by 4 on both sides. And then I finally get n plus 3/4 squared equals 169 divided by 16. As 169 divided by 4 is 169 divided by 16. Now I root the top and the bottom, and I'm going to have to move this over here. Sorry, I'm kind of running out of space. So I have n plus 3/4 equals 13 over, equals plus or minus 13 over 4. Remember, whenever we introduce the square root, you got to make sure you take your plus and your minus. So now I subtract 3/4. So my final answer is n equals a negative 3/4 plus or minus 13 over 4. And when we complete that, we have a negative 13 plus or minus. I said it, but I didn't write it. Negative 13/4, or negative 3/4 plus 13/4 is going to be a positive 10/4, which will leave us with n equals 2.5. And then I have negative 3/4 minus 13/4, which will give us a negative 16/4, which is going to be a negative 4. So there you go, ladies and gentlemen. That is how you complete the square to solve for that equation. Thanks.